concluded our last lesson with a summary of the parts that make up an estimate. In the first lesson on estimation, we learned about the concepts of a point estimate and a margin of error, and we saw how those two together can give us something called an interval estimate. In the last lesson, the third lesson on estimation, we discussed the concept of a level of confidence, which is the probability that that the true value we're looking for lies somewhere within the margin of error of the point estimate. So in this lesson, what we're going to do is talk a little bit about how people create estimates. Our goal is not to actually create them ourselves. We're not going to do that. But by talking about how people create estimates, it'll give us more insight into these various parts. So again, let's use our example of driving from Klamath Falls to Ontario, and let's suppose that we wanted to actually estimate that time. Maybe we don't trust our friend Jimmy Merkley, so we're going to come up with our own estimate. So the way we begin, so we're going to create an estimate. And when people do this, the first thing that they do is they decide on a level of confidence. How confident do they want to be in their result? And the most common level of confidence we'll see is 95%. But it might be on occasion we'd see a 90%. Maybe a 99%. So of course we'd see a 99% level of confidence if we wanted to be very, very certain about something. 90% if we were not needing to be as certain, or just as kind of a middle ground at 95%. Again, the 95% is the most common thing you'll see, and you can probably assume that anytime people don't explicitly tell you the level of confidence, that it's probably a 95%. But anyway, we decide if we're going to create an estimate, the very first thing we do is we decide on a level of confidence. The next thing we do is we gather data. To get a sample mean or proportion. So going back to our example of driving from Klamath Falls to Ontario, what we might do is we might drive that route, say, 10 or 20 times. So we drive from Klamath Falls to Ontario, let's say 20 times. We clock it every time, determine how long it takes us each time, and we average all of those times. And so then we average all those times, and that gives us our sample mean or proportion, and that is the point estimate. So the point estimate is the exact mean or proportion from the sample. But of course, that's not necessarily the exact mean or proportion if we were to continue gathering more and more data. But what we do is we assume that if our sample is large enough, we get enough data in the sample, that will be a good representation of either that mean or proportion in the general population. So again, that point estimate is exact. It's the exact mean or the exact proportion for the sample, but it's an estimate for the mean or the proportion in the population. Now once we have that, at the same time as we're gathering that, we can take our data and do a little more mathematical crunching, and that's what we're not going to do. If we were working with a mean, we would find not only the mean but the standard deviation, and then there's some math that's not terribly complicated, but we're just not going to go there because we're more interested in understanding what these things tell us. But you do a little bit of mathematics and you come up with the margin of error. And the margin of error you come up with is, of course, dependent on what your level of confidence is. So it turns out if you want a very high level of confidence, that you have to allow yourself a large margin of error generally. Whereas if you're willing to go with a little less confidence, then your margin of error can be smaller. So those are related, the margin of error and the level of confidence that you want to have. Also, your margin of error will be smaller if you use a larger sample. The bigger your sample, the better job it will probably do of estimating the value you're looking for your population. So once we've come up with those things, then we have our entire estimate. So again, the main thing I want to emphasize is that the mean or the proportion you get is exact for your sample, but it's only an estimate for the entire population.